All right, I think we're live. That's good. This is Squirrel. Hello. Welcome to the Squirrel Squadron. So you're here, I hope, to hear about tech debt, one of the favorite excuses of engineers. So, engineers are always telling you to turn it off and on again, and they're telling you that they need to rewrite their software. More about that in a minute. And they're also telling you that they have technical debt. And technical debt, oh, it's just a terrible thing. Can't do anything about it. We have to live with this terrible technical debt until we can fix it. And don't let them fix it is going to be the main message today. Okay, so with that little preview, let me let a few people join, and I'll just make a few housekeeping remarks at the beginning before we dive in. The first is this is being recorded, so if you can't stick around the whole time, or if you're watching on the recording, you'll be aware that wherever you are right now, you can come back and watch this anytime. You can share it with your friends. It'll be available on Facebook and YouTube and LinkedIn and wherever else we put these, as well as on the Squirrel Squadron forum. So the Squirrel Squadron forum is the community that we are part of right now that you're having a look at. It's one aspect of it where people come together to discuss all kinds of topics. And we also have the recordings there. So, for example, we have a really interesting discussion going on about how to deal with a engineer who wants to be senior. And unfortunately, that engineer, it doesn't have the right skills. So how do we define those skills? How do we make sure we understand it? And to be extra complex, it's a data engineer, which we didn't have any of until like the last 5 or 6 years. So very new type of role. They existed before, but we didn't call them that. And an interesting discussion for both technical and non-technical people. We have another discussion going on about estimates. How do you live in a world in which people demand estimates, but your team don't make them? How do you make that work? And somebody who I think is here asked that question, and we have a very interesting discussion going on. I've got a response to it, and I have to make sure that that gets live. So Roland, watch out for a further response to your question. What else do we have? So we have these free events every week. So this is the one on tech debt. We had a great one last week on leading a technical team if you aren't technical. And we had some very interesting folks there, COOs and CFOs, and lots of great folks like that. This is a community of technical and non-technical people working together. So we had representation from both. We had a really interesting discussion about what kinds of leadership work. What have we got coming soon? So we had a discussion earlier this week about AI and how to make sure that your operations team work well with artificial intelligence, which we're all hearing a lot about today. Next week, we have an event on technical language. So how do we deal with the kind of techno babble that we hear a lot? That's a Zoom call for anybody who's interested on the executive side. And then in mid-May, I'm giving a keynote address in Krakow, Poland. So if you're around there, or if you want to travel to Krakow, a beautiful place, come and see me on the 18th. I'm going to be talking about why you don't need Scrum. So if your engineers are telling you Scrum is wonderful, I'll tell you why you don't need it. Okay, so, and all of that will be recorded and on the forum and all the other good stuff. So things are going to be there. Don't worry. So I took a poll before this, and no surprise, most of the people who responded said that were planning to come said, we're drowning in tech debt. We've got loads of it. Even people who said they responded one way, said, oh, we have some, said, actually, we have even more than we thought. So it's a perennial problem. It's a sort of thing that you hear from engineers all the time, and we'll talk a lot about it. As we're talking about it, what I want you to do is just give me a quick comment. What brought you here? What level of tech debt do you hear? Are you a person who's fighting it? You're writing code? Are you a non-technical leader of a technical group and you're hearing it and you don't know what it means? Are you in some other group? So in whatever mechanism you're using to listen to me, give me a quick chat comment. I should be able to see all of them here, and let me know what brought you here and what questions you have. This will be a short session if nobody asks any questions. That's fine with me because I'm having fun. So that's the only thing that matters. But more importantly, you'll get more out of it if you ask me the questions that you have. So please first tell me what brought you here, and then be ready to fire questions at me, argue with me, debate and discuss, because that's the way we get somewhere as technical and non-technical people learning together in the Squirrel Squadron. Okay, so let me figure out where to start. Well, I'm going to start with the World Chess Championship, which I'm sure all of you are following as closely and with as great interest as I am. Probably not. But some of you may at least be aware that there are people who play chess professionally. And what I want you to imagine is, and believe me, I'll tie this to tech debt, don't worry. So I want you to imagine what you might have seen of two people playing chess together in a tournament. So very serious professionals playing chess. You might have noticed that they have not 32 pieces, right? So there's 16 white pieces and 16 black pieces, but there's another very important piece, and that's a thing called a clock. And the clock sits next to you. Let's see if I can, the board is over here, and try to do my screen sharing here. The board's here, and right here it's called a chess clock, but it's actually two clocks. So there's a clock for you that you're my opponent, I'm playing you, and there's a clock for me, and both of them have a certain amount of time on them. If either of them gets to zero, the person who has the zero loses. So what you can't do in a professional game of chess is just sit there and pretend to be thinking until your opponent falls asleep and then make a move real quick. Not allowed to do that. And the chess clock was introduced in order to make sure that people actually finished, because there's no other mechanism within the game itself to force people to make a move or to take action. And we have clocks in other types of games, but it's really interesting how the clock is being used in this particular World Chess Championship that happens to be going on right now. There's two really exciting players. They're very, very different styles. They keep beating each other, and so the lead goes back and forth. It's very dramatic and interesting if you like chess. Okay, not all of you may feel that way, but I certainly do. And I've been having a blast watching it. And this 33rd piece, this extra piece that's not on the board, has played a huge role. One of the players is a very fast player. He tends to finish his thinking quickly, and he makes a decision. Sometimes he makes a stupid decision. So he gets something, and the commentators say, oh my God, this is wrong. And you look at it and you say, how could he do that? Well, he was playing too fast. The other guy tends to really think for a long time, and he thinks too long. So his time gets very short, and then he has to make moves instantly. Then, of course, he gets behind, so he then makes more mistakes in that situation. What's happening there is they're managing their debt. They're managing their resource in very, very different ways, and it's having a huge effect on the game. In yesterday's game, the slow player, who's Chinese, really got stuck. He had a lot to think about, and he had 5 minutes on his clock, and then he had 4, and then he had 3. He got down to 45 seconds, and he finally made a mistake because he couldn't think of anything else. And then he had to play nearly instantly, and he lost very quickly. That's an example of incurring some debt. He said, man, I have to think about this more. I have to put more in. I have to use up some of the time on my clock. But he didn't have a plan for paying it back. He didn't have a plan for addressing the debt that he had incurred, the lower number on his clock. The other guy, who was moving fast and also making mistakes, made his moves more quickly. He didn't incur as much debt. Now, that happened to play against this guy in this case. In other cases, it's gone exactly the other way, where the fast guy doesn't incur enough debt. He doesn't think enough. He makes a mistake. The other guy takes longer, incurs debt, puts himself behind on the clock, but actually comes up with the right move, gets ahead in the game, and plays better. All right, how is any of this linked to technology? Technologists make the same kinds of mistakes and make the same kind of trade-offs in building software. So the origin of this notion of tech debt is someone on a thing called the C2 Wiki, if you want to look this up, a guy called Ward Cunningham, if I remember correctly, who said, we have this phenomenon that keeps going on, and I want to make an analogy to finance. He didn't make the analogy to chess. I think it's better in chess, but his analogy was to finance, where we all have credit cards. And sometimes we say, oh, I don't have enough money in the bank right now, but I'm sure I'm going to get more. So I'm going to incur some debt. I'll get the thing. Maybe I'll even get the thing that helps me make more money, and then I'll pay off the credit card. And very often when people do it well, they'll get some money, they'll get an item, they'll use it to earn some more perhaps, and then pay off the credit card. If you have a plan to pay off your debt, life is good. If you don't have a plan to pay off your debt, it doesn't end so well, right? Because you get more and more into debt, and you can cause yourself more and more problems. And he said, this kind of looks the same. So sometimes we incur this technical debt, and we ought to be more thoughtful about it. Just like if you go into the shop and you buy something with a credit card, and you don't think very much about whether or not you can pay it off, you can get yourself in a lot of trouble. You buy lots of shiny things with no ability to pay for them. But if you make a plan and you're thoughtful about it, you can actually get ahead. You can get some helpful things. You can then pay them off, and then you can have more money to do more. So he said this would be a useful way to think about technology. Unfortunately, it has become the world's biggest excuse. And I'm very sad that it's been so misused because what it's become is sort of a universal comment. Well, we just have technical debt. It's become almost like a force of nature. It's as if you said, well, I don't know who spends money on my credit card, but the statements keep coming and I have to keep paying them. And, sorry, we can't afford the rent this month. Sorry, we can't afford to have supper. But, there's just this force of nature here. These credit card bills keep coming. Credit card bills came from somewhere, right? They didn't just appear from nowhere. They came because you pulled out your credit card and you spent on something. The same thing happens in technology. And so the first thing I'm going to advise anybody listening is let people talk about technical debt. It's very helpful, but always make sure you talk about what the origin is. Where did this technical debt come from? How did we obtain it? Sometimes we don't know because we've inherited it. In the same way that you might say buy a business and then you discover it has a bunch of debts, you didn't find it in your due diligence. That can happen, and it happens when people leave an engineering organization or there's turnover in the team. Somebody moves to another part of the organization, and you say, well, gosh, I don't know who made these decisions, but they don't make any sense. The debt is here. That's valid, but it is very useful to remind ourselves where it came from and why we knew about it. Because often you're hearing about the technical debt at the end of a project and somebody says, oh, that's why we're late. No, wait a minute. We knew about it when we started, so we should have incorporated that. I'm going to say a lot more about that, but let me come to comments and questions. This person, I don't know who it is, so I apologize. I just see LinkedIn user says, I remember a software service company we both know. So this must be somebody who worked with me. Good to know. Where the build was so complicated that no one could change it. And eventually we just dumped it and started over. Now, this is a very common way to address technical debt. It's the equivalent of declaring bankruptcy. So we'll keep going with the finance example. Unfortunately, in chess, you can't do this, right? You can't just say, hey, let's start a new game. I'm out of time. No, you just lose. So that's why I like the chess analogy better, because in finance, you can actually declare bankruptcy. In business, in software, it costs you an awful lot to have tech debt. And in this case, I can think of several examples. I'm not sure which one this is. Hi, Steve. Nice to see you. So I think I know which one Steve's talking about. But yes, you have to dump it and start over again. And that has a very high cost. It's not like bankruptcy, which at least in theory allows you not to go to debtor's prison at least, and has some cost to you, but you can kind of start with a fresh slate. That doesn't happen. So when you incur tech debt and you don't have a plan to pay it off, and then you get so much that you can't continue, it's not a free restart, not a get out of jail free card to tear it down and start over. I'm going to say more about that, because if your engineers are telling you to do that, they're almost certainly wrong. So let me come back to that. Roland is there, says, I have to deal with tech debt at several levels. Some I'm responsible for, some is inherited. We talked about that. Some is elsewhere in the system. Some of it inhibits flow, and some of it is incurred on purpose to increase flow in the short term. That's what we're going to talk about in just a minute. And I think this is Steve continuing. I just see a LinkedIn user. It's not debt, it's an unhedged option. I'm not going to go into the finances of that, but absolutely, Steve, you're right. There's lots of ways you can enhance the finance analogy. And Steve knows an awful lot about financial services and fintech. He's survived many banks. So I know that he could talk about that in a way that makes sense to to many of you, but not all of you. So I'm not going to pursue that. Ward's point was that code quality should always be maintained. His debt was missing functionality. Okay, well, you know Ward's and I don't. So Steve, I'm going to defer to you on that one. I'm okay with people incurring code quality debt that they know how to pay off. I would prefer not. I prefer not to have any debt at all, but I'm okay with incurring debt that you know how to pay off in many different directions. So let me tell you about some inherited debt. And this is one you might be able to use if your engineers say, yeah, we've got the worst debt ever. Nobody has this much. It's really terrible. I've never seen it this bad. I'm going to tell you about something that was worse. So I worked at an e-commerce company in the sort of 2012 period. And this e-commerce company had a very complex mechanism, had a really innovative business model, worked really well, but it involved selling 4,000 new products every week. So if you know anything about e-commerce, you know that things like Shopify are designed to deal with a fixed list of products. And maybe you add 10 a week, or if you're ASOS or somebody like that, you might add 1,000 a week. But 4,000 a week is way beyond what off-the-shelf systems are ready to deal with. That's okay, because the founders of this business, way before I came along, this is why the tech debt was inherited, they hired a very clever person who happened not to be trained at all in good software practices, but he was brilliant. He was absolutely creative and thoughtful and really careful. He just hadn't built anything the normal way. Imagine that if you bought a car from a car company that had no people who had ever built a car before. It might have 7 wheels, and it might, drive along on its roof or something like that. It might get where it was going, but it would look pretty weird. This is what this software was like. And it did what it needed to do. It handled 4,000 products a week. We had millions of happy customers. We were doing well, but it was built on what we would call spaghetti code. That's another phrase that you've probably heard from engineers. And at one point, we went to the very brilliant, creative person who built it all, and his name was Dillian. And now I can't, and if Dillian's here, I'd be happy to talk to Dillian. Dillian, you're an old friend of mine, and I hope you're doing well. Dillian was Bulgarian, and I can't do a Bulgarian accent, so I will just do an accent, and you'll have to replace it with Bulgarian as best you can. Maybe you can use AI to do that if you're good at that. So Dillian had this Bulgarian accent, and he was the first person I ever met who smoked an e-cigarette. Those were new in 2012, or at least new to me. And so I'm going to do my best Dillian, but it's not very good, to give you his response when several of us engineers went to him and said, "My God, Dillian, this spaghetti code, we're having terrible time working with it. We don't understand it. We're having a real challenge actually getting anything done." And Dillian said, "I agree. This system, it is spaghetti code. Yes, I've written spaghetti code. But it is nutritious spaghetti. All of you have jobs because of my nutritious spaghetti." So I always remembered that, and I thought that was a very helpful way to think about incurring debt. He knew that he was not a software engineer by training, that he hadn't built the system in a way that was going to be easy to maintain. But none of us would have been there had he not done that. So I was very happy that he incurred that debt. And to Steve's point, man, did they ever incur code quality problems, right? So, and I'm glad he did that. It wasn't, as Steve says, the original notion of technical debt, but I think it's a reasonable use of the term. And this system certainly had it. Now, here's what I'm going to tell you about it, which is that we worked to fix that. But what we didn't do was one of the many things that people often, Steph says we need that as a GIF. Excellent. I'll work on that. Well, maybe you can make one if you feel like it, Steph. Thank you for being here. One of the many things that you hear from engineers is, look, this is so bad that we have to tear it down and start again. Steve was referring to a system where he and I did that long ago. That can work, but it is tremendously risky. And often the new thing that you create that is taking over from the old debt-ridden system after you declare bankruptcy doesn't do what you need it to do. And there are horror stories of doing that. We didn't want to fall into that trap. And so what we did was to gradually replace pieces of the existing system and to live with all the problems that the debt caused for us. So, for example, we would have regular outages. You'd make a change and it would take down the entire system. Nobody could buy anything. The payment page wouldn't open. This happened all the time. We didn't fix it. Now, how on earth could we have done that? Well, luckily, we weren't building a nuclear plant. Remember, this is an e-commerce site. This is a cheap deals site. This was not a high-end site where people had high expectations. They expected to get cheap stuff. And so because they had those expectations, they were quite willing to hit the refresh button. So what we did is we made sure the engineers were sitting very close to the customer service people who would detect problems right away. They'd see chats and phone calls and things, or notice it themselves. And we would make a change, and then the customer service people would start screaming 60 seconds later. And we made sure we had a giant red button. I can't remember if it was a physical button. I don't think it was, but imagine it was physical. We just hit this giant red button and it would put the system back the way it was. So we managed to do that. And that allowed us to work with this terribly debt-ridden system. Now, what's important about that? Here's the important principle that I want you to remember. we were able to understand the business need. The business need here was have a system that's rapidly changing. It wasn't have a system that was stable. That wasn't important for us. A nuclear power plant better be stable. You're building, I don't know if Starship went off today, but Elon Musk probably cares about whether the spaceship actually goes the right direction. If it turns around and hits the Earth, he's probably unhappy. So we're going to want to have a much higher quality standard there. We might take different actions. In this case, we understood the business context well enough that we could take actions that appropriately paid down the debt. We were working to pay it down, but did not involve complete bankruptcy. And we were able to take those steps because we measured the value of paying off the debt. We measured the value of building the new features, and we were able to balance those two. So when engineers use technical debt as this kind of general excuse, well, we have technical debt. That's why we can never tell you how long things are going to take. That's why we can't finish these things. Tell me in business terms. Now, that's going to be a huge challenge for them. That's always difficult. Us engineers aren't necessarily good at speaking business language, but you can help them with that. So you can ask them, for example, what is it that's going to go wrong if we try to release this new software today? And in our case, when we looked at that, we said the system might be down. And everybody said, sounds good. Can we recover? And we said, well, yeah, actually, we can hit this big red button. They said, great, let's do that. And that worked out very well in our context. Please don't misquote me. Steph, don't make a GIF of this and tell everybody Squirrel says break your system all the time and hit a big red button. Not true for lots of environments, but there are other things that you can do, and you can ask me about what those are. Steph is entertained. Okay, good news. Right. So let me keep going, but please argue with me and ask questions, right? I've just said some very controversial things. Some of you probably disagree, so I would love to hear what you disagree about. Okay, so somebody at that same company, having noticed what we were doing, said, I really expected you to come in and rewrite all this. And I said, well, yeah, we are, but very slowly. We're dealing with this. We're paying down the debt slowly. And he said something very wise to me. He said, every engineer I've ever met wants to rewrite everything. They see everything as technical debt. Why is that? And I didn't know at the time, but I can tell you now. The reason is that software is much easier to write than it is to understand. And depending on how many shortcuts you've taken along the way, you can make it even harder to understand. But even well-written code is a very complex description of a very complex system. You can imagine all the complexities that go into something like Midjourney, right, which makes beautiful artwork out of pretty much everything on the internet. If you were going to try to understand even a small piece of that, that would require quite some substantial analysis. It's not a simple system in any way. It would be much easier to write one. And if you wrote it, then you would have the context and all the information in your brain. And so if you're wondering why are your engineers always saying things like, this system's hopeless, nobody understands it, the people who wrote it are no longer here, or they can't explain it to me, I wish I could just rewrite it. They're not irrational. They're not doing the wrong thing. Doesn't mean you should agree with them. Doesn't mean you should let them go and rewrite the system. There are lots of things that you can do about that. Steph says he's pausing on the gifts. Thanks heavens, I'm not going to be a viral on Reddit. That helps me very much. Thank you. Okay, so let me give you a step you can take, something that you can try the next time an engineer comes along and says, oh, well, there's technical debt here. We can't do some feature. We can't complete this activity. When an engineer says that, ask them if they've ever seen the movie Independence Day. And I hope some of you have. If you haven't seen it, you've probably seen a movie like it, because the main thing that happens in Independence Day, or at least the most memorable thing for me, was that there are spaceships, beautifully CGI spaceships, that park themselves over every city on Earth. And those spaceships build their they open their sorry, I've lost my words for a second. They open their portals. I couldn't think of the word for a second. They open portals underneath, and some light comes out. And actually, some humans say, "Hey, hurrah! It's nice to see you, aliens. Nice to visit you." And then the aliens start shooting, and they destroy most of the Earth, and great battles ensue, and so on. But when I'm talking to that engineer who says, "I really need to rewrite all this. I have to tear it all down. I have to restart. I can't work with this code," I say, what if the aliens were parked over all the different cities of the Earth, and instead of starting to shoot, the portal opens up, the light comes out, and the aliens announce in a nice alien voice, Take us to your leader. We want you to, whatever it is you want them to do, build feature X without rewriting the code. Now, one of two things will happen. Either the engineer will say it is completely hopeless. There's no chance that we could possibly do it. They're either not being honest or it's really a bad situation. But I can tell you that even Dillian with the smoking in the Bulgarian accent, his code was not that bad. So I would be astonished if that were the case. Press them a little harder. Typically what they'll say is, well, if we were going to do that, we'd have to make this compromise. The system might not scale. It might not be that so many people can visit it. We might need a bigger database server. We might need to compromise on some of the features. People will only be able to log in the morning, not in the afternoon, or it won't work for certain administrators or for certain people with complex situations. But if you're telling me that we have to work with this, here's the compromise that I would have to make. If you can get the engineers talking in terms of trade-offs, then you can discuss in terms of debt, in the original Ward Cunningham meaning of it, rather than the kind of universal excuse. You get out of the, well, debt is hopeless. It's just here. It's a force of nature. We can't do anything about it. Into, well, wait, here's what a payoff plan would look like. And if this sounds like a real financial advice, it's what you give advice, how you give advice to people who've gotten themselves in trouble with credit cards, right? Is you tell them, what could you do to deal with this? It's not that you kind of stick them all in a drawer. That's how they got in trouble, right? They stick all the bills in a drawer and they try to forget about them. Instead, take one of those bills out, figure out what it is you could do to pay this down, take steps that are appropriate that aren't going to bankrupt you or put you out of your house, and when you're dealt with that one, deal with the next one. That's the same kind of discussion that you want to have with your engineers. And once you get them thinking about Independence Day, they're in trade-off mode. And if you can get them to switch modes like that and be flexible with them, you can get a long way. I'll say more about that in a minute. Let's see. We have, I think, Steve again. Most people have never worked on a really good system, so they don't know how to make the trade-offs. Understood. Yes, Jeff Goldblum was in Independence Day. You've got the right movie. So dealing with the people who've never seen a good system, absolutely. And because people haven't worked in an environment where there isn't technical debt, where somebody really hasn't made huge amounts of trade-offs, that's one reason they think everything is technical debt, because they've only seen that. So you have kind of a mindset among engineers that technical debt is unavoidable. It's everywhere. Everyone has it. That's not the case. Not everyone is in debt. Not everyone is running out of time on their chess clock. Also, not everyone has a system that's full of technical debt. And you can work with it. So the fact that it is everywhere means that people have found ways of working around it and dealing with it. Okay. What else have I got here? I've gone slightly out of my order. So I want to make sure I get to everything. Right. So now I really haven't quite helped out the non-technical people quite as much as I'd hoped to. And that is, what actually is technical debt? Let me just give you a little bit of color about what it actually means. And I'll give you an example that literally came up on a coaching call a few minutes ago. So somebody was telling me first that they needed load balancing. This is starting with the technical solution. This is the kind of thing that people say when they say, we need to declare bankruptcy, start over again. So I said, hold on, slow down. Now, you're telling me about load balancing. Tell me about what the business problem is. And eventually, after a little bit of iteration, we figured out that the business problem is that sometimes there are too many people using a certain service, a certain part of the system, and those people can't log on. If you get more than so many, the next one can't log on. I said, that sounds pretty bad. We should fix that. And they said, yes, that's why we need load balancing. I said, hold on. That's a tear down the system, replace everything solution, and it may not work. What they were describing was a situation where it turned out the storage of the data was so bad that every time those people logged in and tried to do their normal work, they would ask the computer to do huge amounts of work. It was work that the computer I'm pretty sure didn't have to do. And one of the things I told this non-technical person to do was go investigate and find out, why is it the computer is doing this much work? Because it doesn't make any sense. It's looking for basic financial information. These people are financially minded folks who are logging onto the system, looking at the transactions that have gone through it. And we kind of know how to handle transactions. This was not Facebook volumes. This is not Google. This is not anything like that. databases should be able to handle that. We should be able to manage that amount of data. Go find out why it is that it's taking this much. Almost certainly somebody took a shortcut somewhere. And they said, we'll store the data this way. This is the way that looks right to us today. And they stored it in a way that then makes it hard to get back. You could imagine that, for example, you do what I do, which is when I get receipts for my business, I stick them in a folder, actually stick them in a pocket of my rucksack. And that pocket of my rucksack is just full of loads and loads of receipts. So if somebody says, I need the receipt from 3 months ago, I got to go dig through all the receipts and find the right one. That was an example of a shortcut that I took. It doesn't burn me very much because I don't need old receipts very often. And actually, these days I take a picture of them so I can search on my phone. It's a little easier. And if I really needed to do something better, I would store it in a better way. I might store it by week or store it by who I got the receipt from or something like that. And that's what this company probably is going to need to do once we find out why this data has been stored badly. But the point of the story more is for you to understand, if you're not technical, what do people mean actually by technical debt? They mean data is stored in an unhelpful way, the path, the steps, the algorithm that someone follows in order to decide something is poorly documented or doesn't work very well or isn't written in a very clear way. There's a user interface that's confusing, and users find it hard to understand, and developers find it hard to make sure that step 5 always comes after step 4 when you click the next button. It's those sorts of shortcuts that someone takes for very understandable reasons, often to get a feature out quickly, to solve a problem, to deal with a customer need. And the problem is no one makes a plan to pay it off. And that's when you get into trouble, when you make loads and loads and loads of those decisions, and there's no plan to deal with it. So I hope that's a helpful explanation. One of the worst parts of a tech mess, this is Steve again, I think he knows everything about tech messes, is that the engineers believe they will be held responsible for failures, delays that are not under their control. Yes, well, I would say the engineers are responsible for dealing with the failures or delays, but I'm never a fan of people being held accountable. I guess I put it this way. They need to give an account, and the account might be, we took some shortcuts before we got here, and this is what we had. Here's our plan to deal with it. That's being accountable. Being held accountable never sounds very good, right? You kind of want to hide when you're being held accountable. And that's when somebody says, oh, your fault, Steve, you built the system badly, you did it wrong, which of course is inaccurate in most cases. Even if Steve did build it, he often did it, took a shortcut, which was the best he could do at the time. It's what he understood. It's what his skills were up to. It was how he understood the customer's needs to be. You know, when I started sticking receipts in my rucksack, I did that because I didn't have very many, and I thought that was a pretty easy thing to do. Now I'm kind of in the habit of doing it. It's probably suboptimal, but it's not killing me. If it started to kill me, I would need to do something else. Would I hold myself accountable and say, Squirrel, you did a terrible job? No, I put the receipt somewhere. At least I didn't lose them. So that's my view on what we do with technical debt. Steve says, working with someone else's mess. Absolutely. You're working with someone else's. Should you be blamed for it? Certainly not. And so I don't think that's very helpful. However, giving an account of what you're doing with someone else's mess, that seems like it is your responsibility. So I would put that down to you. I think you'd agree with me, but you're welcome to disagree. All right, so let me tell you what another client of mine did in order to manage their technical debt. So, and they have an interesting combination of both technical debt and product debt. In other words, they've built their product in a way that's not very smart, and they know that. And they took shortcuts in order to meet client needs at the time. And also the code that's underneath that doesn't make much sense. So the product doesn't do what it's supposed to do. And however the code might be written, and the code and the database and all the other things that are technical underneath that also don't make as much sense. This is a pretty common pattern. It's pretty common for people to make shortcuts in both, and for a misunderstood system not to be running as well as a well-understood, well-oiled machine. But often you can't create that. So this client of mine said, well, what on earth can we do to kind of get ourselves out of this mess? Because the main symptom, again, I went back to the symptom. I said, what's the business need here? How did you, how does this manifest? How does this cause you problems? And they said, well, the main thing that happens is our salespeople go to the customer and they say, what would you like? And they write down whatever the customer would like. And then they bring it to us and they say, we don't know what the product does, but it needs to do this. So would you please, go have it do all these things? And this doesn't end very well, as you can imagine. And many of you have been in this situation where you're dealing with some obligations that someone else has made. But what hasn't happened is any kind of dialogue about whether those are achievable. That this doesn't work out so good. And so what we said was, we can deal with this debt without fixing it. In other words, what we didn't do was embark on a program of completely rewriting everything, or even rewriting over time. We said, what we're going to do is make sure we have a very clear language for describing what our system actually does, and how good it is at doing that. So some things it's not very good at doing this one. It kind of works, but not so good. It works pretty well over here. And man, this just sings. This part works great. So we defined tiers, or sort of levels for the salespeople, so they could actually have some understanding of what was available. You can think of it like a wedding cake. So on the bottom layer, the widest layer, that's the things that work really well. They're reasonably well designed. We can maintain them. When a customer asks for it, we can deliver it to them, and we can get those things done very quickly. So, of course, those are the cheapest. So the bottom layer of the cake has the most, in their case, the most functionality. It's the cheapest layer. And, if you want one of those, hey, we can deliver that to you in a very short time. The next layer contains things that require some customization, improvement, maybe some feature build. You have to do a little bit in order to make the system solve these problems. And most of that can be done by customer service. You don't have to involve developers too much. It doesn't touch the worst debt-ridden areas of the code, the places where the equivalent of the receipts are just shoved in the bag. So it doesn't have the kinds of costs that the others do, but it has some cost. It's not zero. And so that's kind of the next layer. And then the layer above that has somewhat more customization, more features that need to be built, and more. And so you get on up to the top layer, the little tiny one with the people who are getting married on the top, the little figures. And that one, which is the smallest, we hope we don't have very many of these, because they're huge investments, right? We have to do tons and tons and tons to build all of these customizations and improvements and features and so on. And of course, the cost increases as you go up the cake. Now, the benefit of having defined these is happening all over the business. It's really, really good to see, because the first thing that happens is the engineers have a way of talking about the costs and the estimates and why things are happening the way they are. There's no longer kind of the generic excuse, well, our code is debt-ridden, so of course we can't tell you when it will be done. What they can say instead is, well, you have one feature here that's close to the top of the cake. That's one where we don't give so many guarantees. That's really tough to work with. It's very expensive. We're glad you charged a lot of money for this, because this isn't going to be quick and it's going to be complicated. Here's another feature that's here at the bottom of the cake. That'll be done tomorrow, because we know exactly what to do. We've done many of those before. We know how to finish that. That we can be very predictable on, and it doesn't cost as much. So they have a different dialogue about technical debt, and they certainly still talk about it, but the technical debt is concentrated at the top of the cake where it's more expensive, which makes sense, since if your customer is going to want to work with an area where you have a lot of debt and challenge, they should pay you more so that you can pay off the debt. That would be a good way to structure your business. But a very interesting other thing also happened at the same time, which is once the salespeople actually understood this cake and they understood where things fit and how they work together, they said, you know what, when we think about this, there's a certain class of our customers, there's a type of customer that we sell a lot to, and those customers all exist at the top of the cake. Everyone is right up here, they're their best friend, they're the best man, they're right next to the people who are getting married. And that means that we're going to have to charge those customers a lot of money. And the engineer said, hallelujah, sounds great. Let's charge a lot of money. That sounds like a good thing. And you can keep selling to them, and we'll all get rich together. We need to hire some more engineers, but we can do that. And the salespeople said, no, wait a minute. These are also the cheapest customers. These are the ones who don't want to pay very much. Maybe we shouldn't sell to these people, said somebody in leadership. So we had a completely different discussion about whether this was a good idea or not to service this debt at all. And this is a case where you can actually cancel the debt. So I talked about going bankrupt and sort of replacing it. An even better thing to do is to throw it away and not replace it, which is what they're considering for some of the bits at the very top of their cake. Because once they discovered the actual cost, they discovered the customer doesn't have an appetite to pay that cost. They're already paying it themselves, so therefore they're upside down, right? They're charging a small amount and having a high cost. That's a good way to go out of business very quickly. And so suddenly they're having a discussion about whether to be in that market, whether they should sell to those people at all. Now, I don't know how that discussion is going to end, but it's much more productive than here's some things for you to build. Oh, sorry, we have technical debt. We'll see you in a couple of years, which has been the dialogue up to date. So I wanted to offer you that technique. Define a language which helps people to talk about the debt, helps people to decide where the debt lives and where it doesn't. And at the same time, consider canceling the debt, saying, look, I'm just going to walk away from this. We aren't going to pay it off. It's the equivalent, I guess, if you have a mortgage of posting the keys back to the bank, right? Saying, I don't want this house anymore. I won't pay it back. You can have it. I don't want to continue with this. And that's actually very healthy. Unlike the declaring bankruptcy version, which costs you an awful lot of money, that causes a lot of pain. Okay, so I'd love more questions. I've come to the end of what I was planning to talk about here. I hope I've helped you understand more about where technical debt comes from, what it means. You can think about my receipts shoved in my rucksack. So I'll summarize in just a moment. But if you have questions, throw them in the chat now, because if you don't, I'm going to close up soon because I haven't got more to talk about. And I've had a blast talking to you so far and trading stories with Steve and Steph and Roland. And I'm sure many of the others of you who are watching. So throw in questions if you have them. If not, I'm going to conclude with this summary. We talked about how in chess, you can actually decide to take longer on a particular move, but you better have a plan how to make the rest of the moves very quickly. You better have a good plan as a result of what you've invested. And when you don't do that, you get yourself in a lot of trouble. That's what happens when you take out too much debt in your software or on your credit card. And that's the origin of technical debt. It's the idea that you can make a choice to take shortcuts. As Dillian, the Belgian with the e-cigarette did. He said, look, Belgian, what did I say? Bulgarian. He had to make a bunch of shortcuts in order to get live and make sure the nutritious spaghetti gave all the rest of us jobs. And that was a good trade. However, it caused us a lot of pain later, just like the chess player has to make very fast moves after having a big, long think. So that's where technical debt comes from. That's the idea of it. And there's ways you can deal with it. So you can deal with it by working around it. So you don't have to address it by fixing it, declaring bankruptcy, spending huge amounts of time working on it. You can do small amounts. You can pay it off in an installment plan. You can ignore parts of it and deal with the business needs that exist. And you remember my big red button that we had in order to reset when we had a problem, when we took down the site. That was okay in our case. To trigger that kind of discussion, talk about Independence Day. What if the aliens were above every city on the planet? What would we do to live with this? The answer might be we can do nothing, push harder. Almost always the answer will be, well, we'd have to make this trade-off, spend more, take shortcuts on other features, do things that work less well or less perfectly. And often that's a trade-off that you want to make. And finally, we talked about defining a language, the wedding cake in my client's example, which can give you a way to talk about the debt-ridden areas of your code and to deal with them. And sometimes it'll let you either decide to charge a whole lot more for them. That would be great. Then we can have more folks there and we can pay off the debt more quickly. Or we can actually exit that part of the business. We can say, we're not going to deal with that. That's like canceling the debt, posting the keys back to the bank. Okay, Steph has a question, which is fantastic. Do you think about tech debt differently at different stages of a startup's growth? E.g., early on, optimize for learning, build scrappily, knowing it will be thrown away. Wonderful question, and I know Steph builds startups like they were breakfast cereal. He's just eats them up, which is fantastic. So, Steph, you've been at all the different stages, and you know this very well. But here's how I think about it. I think that you can make trade-offs and choose to take technical debt at any stage. Just like in chess, you could take a long time in the opening because your opponent chose something that was surprising. You could take a significant amount of technical debt, as that e-commerce business did at the beginning, saying, I don't know if this is going to work, but we have to have thousands of products every week, and if it's going to work at all, so we're going to take a shortcut and clean it up later, and we'll have a plan for how we do that. They did. They've hired me and a bunch of other people who are quite expensive, not like this Bulgarian guy who's all by himself, and they had a plan to pay off. So that's kind of the classic example where someone makes a mess early in a product's life or a startup's growth. But you can take debt later times as well, just like in the middle game or the end game of a chess match. You can say, I'm going to take a longer think here, and then once I've got that clearly in my brain, I'm going to go faster. And I could certainly think of many examples where a much larger business, somebody at a unicorn stage, even I can think of examples, will say, we know that we're going to do this less well. Often when you get big, it's harder for you to do things well. In a small startup, the communication lines are shorter. It's simpler. There's fewer people to deal with and keep coordinated. A larger organization clanks along. It has a lot of challenges. Microsoft, for example, tried to build Windows NT. And the reason it's called NT is because eventually they had to really kind of cut off the rest of the Windows organization and have new technology. That's what NT stands for, if I remember correctly. And they had to say, we're going to work a different way because it's hard for us to build. And I think they even bought in somebody else's system and then built on top of that. That's my vague memory of the story. But what you can do, even at that size, is to say, we're going to do this imperfectly. We're going to buy another company and pull in their software, which we don't understand very well, which isn't in a technology that's optimally suited for this. And we're going to make it work, because that's what helps us to move fast in the market. That's what helps us to move ahead and to grow to the next stage that we need to get to. And if you have a plan to pay that off, you do well. Unfortunately, there's so many stories, stick with the acquisitions, so many stories of organizations buying somebody. Somebody gets a bonus, they get a Ferrari, and they're very excited, and they do well individually, but the business shuts down the newly acquired company a year later. And why does that happen? Well, because the company didn't have a plan to deal with that acquisition. They didn't have a plan to bring in their software and make it work. So I think if you take away nothing else from this answer, Steph, I would encourage you to always be thinking about, at any stage, how are you going to pay off the debt? And write that down so other people can understand it. If you happen to disappear in your Ferrari, everybody understands this is how we're going to make this profitable. This is how we're going to use the tech debt, because debt is a very useful thing to have. Our economy would grind to a halt if we had no debt. If you couldn't borrow any money, you could never get a business started. You could never expand a business that's running. And our economy wouldn't function if you didn't have debt. On the other hand, things like consumer debt, where people run up huge credit card bills and aren't responsible about it, that causes a lot of trouble. And I'd encourage you to think about your technical debt in the same way. It's not a blanket excuse. It's something you can control. It's something you can have a dialogue with your engineers about. Well, I don't see any more questions, and I've had a blast, and I think we've covered lots of interesting stuff, so I'm going to stop there. I'll encourage you one more time to go to, and let's see if I can type it in here, squirrelsquadron.com. Squadron.com. There we go. And I'll stick that up on the screen as soon as StreamYard will let me do that. That's where you can come to lots more of these. And we have another next week on technical language. So how do you deal with that? We'll go more into that wedding cake example and others. We have my talk in Krakow on why you don't need Scrum. And literally just before this, I was setting up a live stream in early May that's going to be on artificial intelligence, ChatGPT, those sorts of things, and why they're all going to kill us. Because the person I'm bringing on as a guest is absolutely convinced that none of us will be alive in 20 years, or at least there's a significant chance that we won't be, because those things are very dangerous. I don't agree with him, but I think that's a very interesting discussion to have. So that's the sort of things we do on Squirrel Squadron. So please join up, come along to more of these events, and I'd love to see you on the Squirrel Squadron forum. Thanks very much, everybody, for coming along. Nice to see Martin and Steph and Steve and Roland and lots of the rest of you. Have a wonderful day, and I will see you next week, if not before then, on the forum.